All right, topic 4 is about congruent triangles. There are 5 ways that we can prove triangles congruent. We can use the side postulate, meaning that each side has a corresponding congruent side in the other triangle. Side angle side, meaning in between the congruent sides, the triangles have a congruent angle. And since angle is in between the sides, the angles have to be in between the congruent sides. Angle side angle is very similar to side angle side. The congruent angles surround the congruent side. And then angle angle side, the side that they have congruent is outside the congruent angles. Finally, there's hypotenuse leg, which only works for right triangles. If we know it's a right triangle, and we know that the hypotenuse of the triangles are congruent, and that one of the legs are congruent, then we can say the triangles are congruent. This would be angle side side, but we know that we can't do that unless it's a right triangle. Some things that can help us find some additional information, especially when we're doing proofs, is things from early units. So vertical angles, think that it looks like a bow tie. These angles here we know are always congruent. Alternate interior angles, if this is congruent to this, or sorry, parallel, these are parallel, that's what the arrows mean. And we have this line in the middle, then we can say that the angles on opposite sides of that are congruent, or the ones over here would also be congruent. Corresponding angles, if this is parallel to this, and then we have this line going across, so it kind of makes a letter F, we know that angle Z would be congruent to angle X. The reflexive property means it shares a side. So in these triangles, it's the bottom side here, and then here it's the shared side where they connect. So for proofs, a big helpful hint is that mark what is noted and what you know. So using the all of these things. Label angle or side so that you know which part you're looking at to figure out your congruent statement. And corresponding parts of congruent triangles are congruent only after the triangle's congruent statement. So always start with the given information. So we're given 2 things here. Angle GHI is congruent to angle IFG. That was given. So that would be letter D, given. And then we know something else is given. That would be that GF is parallel to HI. So I'm going to mark those things in my picture. Angle GHI, GHI is that angle here. IFG, IFG is this angle here. So we have an angle and an angle. Side GF is parallel to side HI. They've already marked that for us with the triangles. So I'm going to use the information that's already in the proof to help me kind of figure out what I need to do. So angle FGI, FGI, that's this one here, and angle HIG, HIG, this one's here. What would be the reason for that? Well, those switch sides of our line in between the parallel line, so it makes that zigzag shape. So I know that these are alternate interior angles. So that would be letter F. If two lines are parallel, then alternate interior angles are congruent. And I'm just going to abbreviate alternate interior angles. Then it tells me I need something using the reflexive property. Reflexive property comes up when things are shared. So we're looking for a shared side here, and that would be the side right here, G and I. So I'm going to look at my options. That would be letter E. GI is congruent to IG. So I had the angles I was given, I had the alternate interior angles, and then I have a shared side in the middle. So we only have two options for which property can prove the triangle's congruent. It's either angle, angle, side, or angle, side, angle. So I need to start at one of my angles. We don't have a letter here, we don't have a letter here, and we don't have a letter here. We don't have a letter here, we don't have a letter here, we don't have a letter here. So I need to go the shortest distance. So I can't go clockwise here because that has two x's in a row and we don't want that. So I'm going to go counterclockwise, angle, angle, side. So it's letter B, angle, angle, side. Now that I've proven the true triangle is congruent, I can prove that GH is congruent to IF. GH is congruent to IF because the triangles are congruent. Therefore, all their parts are congruent. Let's look at a couple other examples. You don't have that part in your packet. Which triangle below is not congruent to the other three triangles? Well, we know that the angles of a triangle always add up to 180. So I'm going to find the other angles that are missing in these triangles. 180 minus 70 minus 60 would give me 50. 180 minus 60 minus 50 would give me 70. 180 minus 70 and 50 would give me 60. And angle, again, 60. So they all have this side that has a 9 on it. So we know this is congruent. So now I'm going to look at the angles that are surrounding this side. So I have a 50 and a 50 and a 50 and a 50. I have a 60, a 60, a 60, and the 60's up here. And then 70's up here, 70's up here, 70's up here, 70's down here. So the key thing is that the angles surrounding the side should be congruent. So I got a 50, the 9, the 60. Okay, 50, 9, 60. Good. 50, 9, 60. Good. 50, 9, 70. So that's the one that doesn't work. It doesn't match. Triangles ABE, so ABE, ADE, A to D to E, and triangle CBE are shown on the coordinate grid, which and all the vertices have coordinates that are integers. They want to know which ones are congruent. So ABE and CBE share this side, so we know that they have this side congruent. That side, if we count, goes 1, 2, and then over 1. If this side does the same thing, then we know that those are congruent. So 1, 2, over 1. So all three triangles have one side that's congruent, so that's good. ADE and ABE share this side. Well, let's see if that side is congruent to the side CE. And we're going to count the boxes again. 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. So those are congruent. So we don't know, we know things about two of the sides. We don't have any information about angles, so we're not going to be able to use any of our theorems that use angles. Hypotenuse leg we can't use because we don't have a right triangle, so that leaves side, side, side. So we need to check the other side that we're given. Here we can just count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So those sides are congruent. So now at this point, we know that ADE and triangle CBE are congruent. Well, do any of these answer choices have ADE and CBE together? One, it's not no triangles are congruent. Only ABE and CDE, that's not true because we know ADE is congruent. Only ABE and ADE are congruent, not true because we know those are congruent. So it has to be letter J, but let's check. So we don't know how long AB is, so we're going to use our Pythagorean theorem. This side is 1, 2, 3, 4. This side is 1, 2, 3. And this is the side we're trying to find. We want to know if it comes out to be 5, just like AD and BC. So x squared equals 4 squared plus 3 squared. 4 squared is 16, 3 squared is 9, x squared equals 25. And if we square root both sides, we get that x equals 5. So it is the same as those other two, so all three triangles are congruent. Go ahead and try your practice.